Harvard's most controversial astronomer just made a statement that defies everything we thought we knew about interstellar visitors. Professor Avi Loeb, the scientist who shocked the world by suggesting Oumuamua might be alien technology, has analyzed 3I Atlas's trajectory, and he claims it's not leaving. According to his calculations, this object from beyond our solar system is slowing down, not drifting away into the cosmic void like every interstellar visitor should, but decelerating, adjusting, preparing to stay. If Loeb is right, humanity is about to share its solar system with something that was never supposed to be here, and the silence from space agencies suddenly makes terrifying sense. It began on January 1st, 2025, with what should have been routine. In the thin, dry air of Chile's mountaintop observatories, the Asteroid Terrestrial Impact Last Alert System flagged a faint, fast-moving object, another icy wanderer from the distant Oort cloud, or so they thought. Within hours, the numbers didn't add up. The trajectory was too steep, too fast. By dawn, orbit analysts at the Minor Planet Center in Massachusetts confirmed what no one wanted to see: eccentricity above 1, a hyperbolic orbit. This object wasn't bound to our sun. It came from somewhere else. The designation came swiftly: 3I Atlas, the third confirmed interstellar visitor after Oumuamua in 2017 and Borisov in 2019. But unlike those brief tourists, which carved sharp angles through our solar system and vanished forever, 3I Atlas did something unprecedented. It hugged the planetary plane, threading a near-perfect corridor through the inner system like it knew exactly where it was going. It wasn't just passing through, it was navigating. When astronomers backtracked through archived data, they found Atlas hiding in plain sight since mid-December 2024, but its behavior violated the rulebook. Normal comets brighten smoothly as they approach the sun, ice sublimating in predictable curves. Atlas pulsed, spikes, then lulls, a heartbeat in the void. Then came the detail that made veteran astronomers go silent. The dust tail was bending the wrong way. Instead of flowing away from the sun as physics demands, dense clumps curved forward toward the star, as if magnetic forces were at play, or something inside was exerting control. Amateur observers monitoring Atlas on Discord and Telegram reported something even stranger. The brightness would jump half a magnitude in one night, then fade the next. No known comet behaved this way. The object seemed reactive, almost responsive. Whispers spread through astronomy circles. Fragmenting core, exotic ices, or was it engineered, an object carrying its own power source? As Atlas approached Jupiter's orbit in February, the mystery deepened into something approaching impossible. Mass estimates revealed a shocking problem. More dust and gas were pouring from the nucleus than its size should physically allow. If Hubble's measurements were correct, less than 6 kilometers across, then the outgassing was violating standard physics. At the European Space Operations Center, something changed. Technical logs showed Mars Express and the Trace Gas Orbiter quietly redirecting instruments. Spectrometers built to detect Martian methane swiveled toward the approaching visitor. None of this reached the press. Meanwhile, the James Webb Space Telescope carved out precious observation hours. Its infrared scans detected something alarming: molecular signatures that didn't match any known cometary chemistry. Leaked notes mentioned heavy organics and silicates in abundances that shouldn't exist together. And then, as evidence mounted, the agencies went silent. By late March 2025, the blackout wasn't accidental, it was coordinated. Conference talks quietly removed Atlas from their agendas. Researchers who debated observations on Slack went dark or typed in careful code. The once-open stream of Mars Express imagery slowed to a trickle. The Trace Gas Orbiter's high-resolution passes vanished from public archives. Even amateur astronomers, the watchdogs of the sky, complained that data was being choked off. Mars was now only weeks from a flyby that would bring Atlas within 18 million miles. Closer than any interstellar object had ever approached a planet in our solar system. Close enough for every instrument to capture exquisite detail. But the feeds went silent. Inside the European Space Operations Center, instruments on Mars Express were retuned to detect organic molecules. The Trace Gas Orbiter's schedule was rewritten to prioritize water vapor spectra and isotopic fingerprints. Imaging campaigns shifted without public explanation. Then came the leak that set astronomy forums ablaze. An anonymous NASA contractor released fragments of internal memos. Buried in one exchange was a phrase that sent chills through the community. Trajectory corridor consistent with mission-like approach. Risk assessments embargoed until further review. Mission-like approach, not a comet's path, a spacecraft's. Why would NASA compare an interstellar visitor to an engineered trajectory? While official channels went dark, amateurs refused to stay silent. Users on astronomy forums traded spectrographic data captured from private observatories in South Africa and Chile. One sequence showed carbon monoxide emissions far stronger than any comet at that distance should produce. Another revealed hydrogen cyanide bursts, molecules associated with complex organic chemistry. But the real bombshell came from inside. In mid-April, redacted emails began circulating online. Subject line, data embargo until further notice. Within those lines, references to episodic venting inconsistent with thermal models and the word that ignited everything, structured outbursts. Structured, not random, not chaotic, pattern. What kind of comet follows a pattern? While the world debated whether Atlas was an exotic comet or something stranger, Professor Avi Loeb was running the numbers that no one else wanted to calculate. Loeb, chair of Harvard's astronomy department and founder of the Galileo Project, had been tracking Atlas since discovery. The same scientist who claimed Oumuamua might be alien technology was now analyzing another interstellar visitor with even stranger behavior. His findings were stunning. By cross-referencing positional data from Atlas, Hubble, and leaked Mars orbiter telemetry, Loeb calculated that 3I Atlas was losing velocity faster than solar gravity alone could explain. Not the gentle slowdown of an object climbing out of the sun's gravity well, but active deceleration, like retrograde thrust. In a statement that sent shockwaves through the scientific community, Loeb declared, "This object is not on an escape trajectory, it's on a capture trajectory. Something is slowing it down, and if current trends continue, 3I Atlas will be gravitationally bound to our solar system within the year, an interstellar visitor, staying forever." The astronomy world fractured. The natural camp clung to exotic explanations. Perhaps Atlas was made of supervolatiles that sublimate far from the sun, creating unexpected drag. Perhaps magnetic interactions with the solar wind were breaking its velocity. Perhaps it was fragmenting asymmetrically, producing thrust-like effects. These theories stretched known physics, but they didn't break it. The artificial camp went further. Loeb's team pointed to the trajectory, a flat, precise path threading multiple planetary planes with improbable accuracy. Out of thousands of random interstellar entries simulated, fewer than 1 in 500 produced such a corridor. The deceleration suggested active maneuvering. The structured outbursts resembled course corrections disguised as cometary activity. And the timing, arriving just as humanity developed the technology to detect it, felt less like coincidence and more like schedule. One European physicist, speaking off record, put it bluntly, "If this is a probe, then Mars isn't the target, it's the first checkpoint." By April 20th, the tension was unbearable. At the European Space Agency, meetings stretched through the night. One staffer later admitted that spectrometers had detected isotopic ratios inconsistent with any known solar system object, but none of it went public. Instead, the world's attention was carefully steered elsewhere. Terrestrial crises, political scandals, entertainment drama. Atlas vanished from headlines. Yet behind the silence, preparations intensified. Orbiter schedules tightened. Ground stations cleared bandwidth. Solar observatories aligned coronagraphs for emergency tracking. The blackout window was opening. For Earth, Atlas would vanish into solar glare. For Mars, it would pass terrifyingly close. And for the rest of humanity, only silence. By late April, the Sun pulled Atlas into conjunction, hiding it from Earth-based telescopes. For nearly 2 weeks, the world would be blind. Hubble and James Webb, humanity's most powerful eyes, were forced offline. Their solar avoidance protocols locked them out at the exact moment Atlas reached its most dangerous phase. Only one planet maintained line of sight: Mars. Trailing 18 million miles away, the red planet was perfectly positioned to observe what no one else could. Mars Express, the trace gas orbiter, NASA's CUBE satellites, instruments never designed for this, were hastily retuned. Spectrometers meant for methane detection turned toward Atlas. Cameras meant for dust storms pointed into deep space. Every kilobyte of data was squeezed through narrow communication windows before solar interference cut the signals. Official logs made no mention of it, but the spacecraft were watching. On May 31st, 2025, Atlas swept past the Sun at its closest point. For ordinary comets, perihelion is apocalyptic. Ice boils away in torrents. Fragile nuclei often shatter into fragments. Many astronomers quietly expected Atlas to disintegrate, ending the mystery in a cloud of debris. But leaks told a different story. The object survived intact. If anything, it emerged stronger, its coma broader, its dust denser, its pulse more pronounced. Instead of burning out, it seemed to activate, as though perihelion triggered something within. Then came the Mars flyby. Just 18 million miles separated Atlas from the red planet, closer than any interstellar visitor had ever approached any world in our solar system. For comparison, Borisov never came within 150 million miles of any planet. Yet Atlas threaded this corridor like a spacecraft, executing a precision flyby. The silence from Mars orbiters was deafening. Data streams slowed to a trickle. Images that normally released within days were withheld for weeks. When they finally surfaced, they showed blurred streaks, faint halos, and unexplained anomalies in the dust tail. One image, later analyzed independently, hinted at sharp-edged structures hidden inside the coma. And then came the whispers that changed everything. Atlas released energy bursts in precise intervals as it passed Mars. Too clean, too geometric, too regular to be dismissed as natural venting. To some, it looked like physics. To others, it looked like communication. The weeks after perihelion brought no relief. The silence deepened into something like paranoia. Conference sessions were canceled. Mission teams closed ranks. Even amateur observers found themselves blocked, their instruments too small, their access too limited. For the first time since discovery, the story of Atlas existed only in classified reports and hidden archives. But the object continued on. It did not shatter. It did not accelerate back into interstellar space. And according to Loeb's latest calculations, updated with post-perihelion data, the deceleration was accelerating. Atlas was shedding velocity faster than before. The trajectory that should have slung it back into the cosmos was bending, curving, staying. Today, as October 2025 begins, one fact is undeniable. 3I Atlas is not behaving like a comet. It has defied models, survived impossible conditions, and, if Avi Loeb is correct, is preparing to become a permanent resident of our solar system. The silence from space agencies speaks volumes. Every embargoed dataset, every withheld image, every unanswered question hints at a truth too extraordinary or too terrifying to reveal. Was this a piece of frozen rock tossed from another star by chance? Or was it a messenger traveling with purpose, its mission not to visit, but to remain? If Atlas is slowing down, the next question becomes inevitable. What happens when it stops? For now, the only certainty is uncertainty, and the silence itself has become the loudest message of all. But one thing is clear: if Loeb is right, humanity is no longer alone in watching the skies. Something is watching back, and it's not leaving.